Good morning, Year 10. Hope you're all well. Just going to finish off the Factorising quadratics subsection in the textbook. There's just one special case you need to be aware of, and that's the final thing we're going to do today. So the objective for today is to identify a special type of quadratic and use the correct method to deal with that one. Okay, so before we begin though, just need you to observe a pattern when expanding brackets. So let's say we wanted to expand the bracket x plus 4, x minus 4. Then we should first times second bracket, second times second bracket to get x brackets x minus 4. And then 4 brackets x minus 4 as a start. And then expanding the brackets, x squared minus 4x. Expand the brackets, 4x, 4 times negative 4 is a negative 16. Use your calculator, don't believe me. And when you simplify, minus 4x plus 4x, well, they cancel each other out and you're left with x squared subtract 16. Now, let's suppose I asked you to do the next one. If you actually did the same kind of workings, x plus 5, x minus 5, so very similar to the one above with just one number changing, that would actually expand to x squared minus 25. Okay, again, you could do that in your own time, but that's what that would expand to. You might start spotting the pattern now. If I had x minus 7, x plus 7, all I've done is like swap the brackets around, but the pattern is the same: a plus and a minus, plus and a minus, 5 and a 5, 7 and 7. This would expand to x squared minus 49. And you can do this with anything as long as they look at the same type, so an x and an x, a plus and a minus, and the same number. So what would x plus a brackets x minus a expand to? And the answer would be x squared minus a squared. And that's the pattern you need to know for today. So stuff you need to know is x plus a, x minus a. So you've got these, same number, different signs. That always expands to x squared subtract a squared. Okay, and in particular for today, going in this direction is the direction we're interested in. We're trying to factorize x squared minus a squared. Because if you remember from a few lessons ago, you were given two-termed quadratics, something like x squared plus 3x or whatever, and you were aware that they went to single bracket factorising. But now we've got two-term quadratics, but they're going to double bracket factorising. So this is the one unique case now where you've got a two-term quadratic, but they're not going to factorise to single brackets. So let's see what that would look like as an EG. Should be EG number 2, not EG number 1 again. Okay, x squared minus 9. X squared minus 9. So what would I imagine you would do is you would, in an exam, probably think, oh, this must be expanding, this is two terms, so it's probably going to be the single bracket. But if you tried single bracket factorising this, it doesn't work. There's no common factors. But then you should notice this pattern: x squared, minus, a squared. What would that be? That would be effectively x squared minus 3 squared. And then you can work backwards. And then this is x plus 3, x minus 3. So you skip straight to the answer. There's no need for any other workings. It's just spotting this special case and working backwards. Okay, this special case is called difference, because this is subtraction. Difference. These are two square numbers, x squared and an a squared, so it's called a difference between two squares. Or difference of two squares. So call the difference of two squares or difference between two squares. And that's the pattern, that's what it's called. So I'm going to show you where the pattern doesn't work, or remind you where the pattern doesn't work. So this is EG number 3 now. Factorize x squared minus 9x. Again, two-termed expansion. And up to this point, you always thought the two-termed expansions go to single brackets. But we've seen now they could go to double brackets. But why doesn't this satisfy this special case? Well, if you compare, it's got an x squared. It's got a difference, subtract. But this time, it's the x term, which is in there, whereas the x term is not in there, it's the number on the end. So that's the major difference. This one, there is a common factor between these two terms, because if I wrote it out in full, x times x minus 3 times 3 times x, there is something in common. X brackets x minus 9 would be that answer. Whereas this one, if I try to write this one out in full, x times x minus 3 times 3, there's nothing common. So I wouldn't know how to do it. So that's not single bracket. Okay. And my exam tip would be pretty much, if you see a two-termed expansion, it's probably going to be, if you see a two-term quadratic, it's probably going to be single bracket expansion. That's what you should try first. And if that doesn't work, like it didn't work for me there, then it's got to be this special case. So for two-termed quadratics, try single bracket factorizing first. If that doesn't work, it must be the special case. And this special case is called the difference of two squares, or difference between two squares. And that's pretty much it. Now, you guys are going to attempt some questions from the textbook, but the textbook is like a mixture of EG2 and EG number 3. So you have to spot when to use which one, and so on. But the exam tip should help you with that. So that is on, let me get this right. Okay, so that's exercise 3, and you're going to do 3 star today, both of them, and that's on page 316 and 317. So do both of them, and mark your answers with the ones in the back of the book, and then upload your workings to the class notebook. Thank you very much.